Hi folks, we're going to take a look at number 14 on page 333. So here they're asking us to find the point on the x-axis which is equidistant to these two given points. Okay, so again, I'm not going to make any effort to draw these accurately, but just remember where we are on the x-axis. So here this is the x-axis in 3D. Okay, and if you live on the x-axis, it must mean that your y and z components are both 0. Okay, so the point we're working with, okay, I'll call it P, is going to look like x, 0, 0. Okay, and then what we've got is we've got our points A and B. So A is -2, 1, 3, and B is 4, 1, -1, 3. Okay, and we want to determine that point on the x-axis which is equidistant to those two other points. Okay, and the way we're going to do that is by creating vectors from each of the points to my mystery point. Okay, and if these distances are the same, it means the magnitudes of these vectors are going to be the same. Okay, so essentially the equation I have to solve is the magnitude of AP needs to be equal to the magnitude of the vector BP. Okay, and so at this point here we just have to input what we have. Okay, so let's find AP. So here notice how I made P the second point, so I have my variable coming first. So this is x minus -2, so x plus 2. Here's 0 minus 1, -1, and 0 minus 3, -3. Okay, and that's got to be equal to the magnitude of BP, and BP we have x minus 4, 0 minus -1, so it's 1, and 0 minus 3, -3. Okay, and so now we'll just find the magnitudes of these two vectors. So on the left we have x plus 2 squared plus -1 squared plus -3 squared, and then on the right hand side we've got x minus 4 squared plus 1 squared plus -3 squared. Okay, now in order to solve this, since we have a square root on both sides, I'm just going to square both sides, get rid of the square root. So what I'm left with here is what's inside the square root. So let me expand this while I'm at it. We have x squared plus 4x plus 4 plus 1 plus 9. And then here we've got x squared minus 8x plus 16 plus 1 plus 9. Okay, oops, plus 1. Forgot the 1 there. Okay, right off the bat, I see a lot of things are common on both sides of the equation. So subtract x squared from both sides, those go. Subtract 1 from both sides, that goes. Subtract 9 from both sides, that goes. So I'm just left with this linear equation, which means I'm going to have only one answer. Okay, so bring the x's to that side. So we've got 12x, and then the 4 to the other side. So 16 minus 4 is again 12, and so x is equal to 1. Okay, so that means that the point that we're looking for is the point 1, 0, 0. Okay, so a couple of things in this problem. Number one is to identify the fact that if you are a point on the x-axis, your y and z components are going to be 0. And then from there, you set up two vectors and then just equate the magnitude, since we need these distances to be equal. Okay, and then solve. That's it for this one.